Hello, we'll be looking at decimal numbers and binary numbers. So what is decimal numbers first? Decimal numbers are something which you have all seen. It's based on 10 base digits. Ten base digits 0, 1, 2 up to 9. Deci 10. So 10. So it's called decimal because of 10 base digits. And a number is basically a sequence of these base digits. So we can have 7, 3, 2, 5, 6, right? Any arbitrary sequence of these digits form a number. So this is decimal number system. It's familiar to us. It's not that everywhere in the world this was a number system which was used. So this number system, this way to represent numbers was developed in India long back. So it's called as the Indian number system or the Hindu number system. And so then this number system was then taken to Arabs. So they started using it, and then it was taken to Europe, and even until the latest 13th century, 14th century, in Europe they were using what is called as a Roman number system. You know Roman number system, right? And after that, so this number system, the decimal number system, came to be used now in most of the world because of its ease of representation. So compared to, for example, compared to Roman number system, the Roman number system requires new symbols to be used whenever we go bigger and bigger numbers. We are forced to use new symbols, but that's not required in the decimal numbers. So this representation has some nice properties, and therefore because of its ease of usage, this has now become the most popular way to represent numbers. Right, that's the short history of decimal number system. Now coming to binary number system. So deci means 10, and it's called decimal number system because it has 10 base digits. And so what is binary? By. What is binary going to be? Binary is going to be by 2. So 2 base digits, and we will represent the 2 digits by 0 and 1. Right? So, and a binary number is basically some sequence of these base digits. So next question we want to address is, how do I convert a decimal number into a binary number, and how do you convert back? How do you go from a binary number to a decimal number? Right, conversion from base 10 to base 2, so that is from decimal to binary. Right, so let's take an example number and let's do the conversion. So consider the number 75 and in decimal, and I want to convert it into the binary form. How do I do that? First, I am going to create a table, and I note down 75 here, and I divide by 75 by, I divide 75 by 2. And I am going to note down its quotient and remainder here. What is a quotient when you divide 75 by 2? It is 37. Right? 37, because 13 to 2, 60, 60 plus 14, 74. So 37 into 2 is 74, and remainder, it leaves remainder 1. Right? Okay. Next thing you do is you divide 37 by 2. How much is that? 18. 18 into 2 is 36, 36 plus 1. Next, 18 by 2, 9. 0 as quotient. Nine by 2 gives you remainder 1 and quotient 4. Okay, I just filled it for you. We do the same thing and we get these. This is the table we get. And I claim that the binary number the binary number 475 is this sequence. Okay, and to write it, it will be written as 1 0 0 1 0 1 1. So you could notice this one goes here. This is going to be the most significant bit, and this one is going to be the least significant bit. Right? Most significant bit, this is the most significant bit and this is the least significant bit, and you're going to write it like this. This is the binary number for 75. So binary number for 75. Okay. Now, I guess now you know how to do, if I had another number, if this was some other number, we do the same procedure and we can find out the binary number, right? So it's clear that given any decimal number, you can now find out the binary number of it, right? Now going back, if I give you a binary number, how can I go back to a decimal number? That's the next thing we are going to see. Conversion from base 2 to base 10. So base 2 means from binary number to decimal number. So let's consider the binary number. So what was the binary number 475 we had? Let's just have that, and I'm just writing from my memory. Consider this binary number and we want to find out its decimal number. Okay, so what I do first is the following. So let me just separate it out. What I first do is the following. I'm going to note down, I'm going to write 0, 1, 2, 3, 4, 5, 6. So I've written down, this is my number I want to convert from binary to decimal, and I've just written 0, 1, 2, 3, 4, 5, 6 below it. Now I do the following. I'm going to write the following here. Okay. I wrote 1 into 2 raised to 0 here. 1, this 1 comes from here, and 2 raised to 0 comes from this 0. Okay. So this becomes 1 into 2 raised to 1. Okay. 1 comes from here and this 1 comes from here. So this becomes 0 into 2 raised to 2. Okay. 0 comes from here, 2 comes from here, and this becomes 1 comes from here, 1 into 2 raised to 3. I mean, you got the pattern, right? So these two will be 0 into 2 raised to 4, 0 into 2 raised to 5, right? And finally this will be 1 into 2 raised to 6. Okay. Now what we are going to do is, the decimal number is basically the sum of all these. Okay, sum of all of them. So it's clear that any multiplication with 0 is 0, so I can just remove them. What are the rest of the numbers? What is 1 into 2 raised to 6? That's 64. This is 8. This is 2. And this is 1. Right? 64 plus 8 is 72, plus 2 is 74, plus 1, this is 75. So this is the binary number for 75. Okay, so now we have seen both the procedures going from decimal to binary and binary to decimal. Thank you.